LaRosa. I'm the service hydrologist here at the National Weather Service office in Nashville. And here we have a Ward scientific floodplain model. And so what it does is it simulates rainfall over various types of trays that make up either a wetland, parking lot, or a retention pond. And each one of those is going to have a different effect on the river in the model. Some will have a little bit of runoffs and you won't see much response in the rivers and streams. The parking lot, you're going to see a big response. And so it's a good exercise to see how development practices and changes to a watershed affect flooding for similar rain events. This is a tray has a bunch of sponges in it to simulate a wetland and what a wetland does. And essentially what a wetland does is soak up a bunch of water. This tray is our rainmaker. So we're going to pour some water in the tray. It's going to simulate rainfall, and as expected, the sponges soaked up a lot of the rain and we didn't see any of the runoff in our river here. So what happens over courses of heavy rains that lead to flooding is the ground can only soak up so much water before that water then starts to run off. So we'll add a bunch more water here. And now we start to see water go through our river. And if you get too much water, you see an overflow into a floodplain. And that's represented by this area here with the houses. The water is approaching the houses, but it seems to be coming up just short. And that's a typical rain event. You get some heavy rain, the ground soaks up as much water as it can, and then over time that water will work its way through the creeks and streams and rivers. They'll put in shopping centers and parking lots, and this tray here is a parking lot. So with our parking lot we have a little shopping center, and of course we got to have our nice cars. And we add our rainmaker on top of it. So even with a minimal amount of rain, it immediately starts to run off into the creeks and streams. And since the wetland isn't there to absorb it, it starts to approach the houses. And this is how we get flooding. We get too much water running off into creeks and streams, and eventually approaches low-lying areas, roads and houses and things that are closer to creeks and streams tend to get flooded first. Of course, if we could keep pouring water through it, we'd have a big flood. Dams can control most of the water on some of the bigger creeks and streams. But what we've started to do is add a retention pond. And this is a retention pond. Basically, the water collects in here, and then over time it slowly comes out the outlet. If you live in a big subdivision, chances are you probably have one of these. They're pretty inconspicuous. Usually they're covered with trees to make it look nice. But essentially what it's going to do is capture all the water and slowly release it over time, similar to what a wetland does. So now I'll add our parking lot, and our shopping center, and our two cars, and then we'll see what happens when it rains on top of the parking lot. So as we add rain, the rain falls into the retention pond. Eventually the retention pond gets full, and then it comes out the outlet. And of course, it releases at a slow enough pace that it doesn't overflow into the low-lying areas. It just slowly releases it to the creeks and streams at a controlled rate so as to minimize flooding. Well, thanks for watching, and come see us at the Wilson County Fair or at another event. Come see the floodplain model.